At last we get to the quadratic formula. This is in some sense the end-all be-all for solving quadratic equations. There's no quadratic equation out there that the quadratic formula cannot solve. Now, having said that, it doesn't mean you should use it on every single problem, because there are many problems for which factoring is an easier way to go, or the square root property is an easier way to go. So I still think of it as a method of last resort. I'll only use it if one of those other two methods won't apply. Now, there's certainly cases where you can't factor the equation, either because you can't see the factoring or it just doesn't factor. It's a prime polynomial. And there's some problems for which the square root property doesn't apply because it doesn't have the right format. Remember, we had to have x squared equals a number, that type of square equal a number format, and some equations don't have that. In fact, this equation down here doesn't have that format. Now, before we run off and use the formula, let me make a couple quick remarks about it. In order to use the formula, you need to have your equation in that general format. We looked at this earlier. Ax squared plus bx plus c equals 0. You have to have everything on one side, descending order, equals 0. If you don't put it in that format first, then the coefficients, the a, b, and c, they won't be the right numbers. And you plug garbage into the formula, you're going to get garbage out. So the a, b, and c have to be correct in order for the formula to work. One thing that I probably should point out is that the a cannot be 0. That sort of makes sense because if a were 0, you wouldn't have a quadratic equation. So why on earth would you be using a quadratic formula? You wouldn't. So a is not supposed to be 0. That makes sense over here as well because you have an a in the denominator. You don't want that to be 0. One other thing I should mention is if you want to see where the formula comes from, I have a derivation for you of it in the appendix. And if you go to the appendix in the notes, I walk you through exactly where this thing comes from. It's kind of interesting. So for those that are curious, take a look at the appendix. It's in there. All right. Let's proceed to use it on an equation. And I'm not going to do all the examples I have in the notes here. I really encourage you to read pages 298 to 304 to get all the information I have there. But let me just work a couple examples here and give you a couple pointers for the sake of this video. All right, so right here we have an equation. It turns out that this equation is not factorable, so I can't solve it by factoring. And I can't use the square root property on it. How do I know that? Well, an easy way to tell whether you can or cannot use the square root property is notice how the x squared piece and the x to the first power, these are separated from each other. Whenever you have an equation where those are separated, the square root property won't work because the square root property requires you to get the x squared by itself on one side and number only on the other side. If I have an x term somewhere in the equation, that's never going to happen. So you can't use the square root property on this either. That forces the issue. We have to solve it with the quadratic formula. Okay, that's what we're here for. So the first step, of course, is I got to put it in that general format. Ax squared plus bx plus c equals 0. I got to put everything over to one side. So not hard to do that, but that's the very first step in the process. So let's move the 10x over here. And we'll also move the 1 over while we're at it. There we go. Now what do we have at this point? Well, we got 3x squared minus 12x plus 4 equals 0. Now we're ready to roll with the formula. Now, once we've gotten general form, we want to pick off the a, b, and c, which is not hard to do. So the a is the coefficient of the x squared term, which is 3. The b is the coefficient of x to the first power, and include the negative sign with that. So if there's any negative involved there, you want to include that. So b is negative 12. And then c is this piece by itself. They call it the constant term, the term that has no variable in it. So that's going to be c equals 4. All right, so there's your a, b, and c. Now just plug and chug with the formula, and there you are. So let's see how that goes. It shouldn't be too hard. I recommend writing the formula down, especially when you're first getting started, because it'll help you memorize it. But even after you know how to use it, because it minimizes the delay, you might say, from looking at the formula and then plugging the number in. So having it right there when you start plugging stuff in minimizes the chance of fouling it up. Another thing I might mention here is, how fast do you want to work this? Not too fast, and maybe not too slow either. Looking for a sort of a happy medium there, pacing that's in the middle that is not too slow or too fast. Here's about how fast a problem like this is a right speed, you might say. So what can we do? Well, let's go ahead and do the negative b piece here. Since b is negative 12, what's negative 12? That's going to be a positive 12. So we'll go ahead and write that down. And now we're going to go inside the radical. And this is the part that you got to be the most careful with. Make sure you get the stuff inside there correct. b squared. Well, what do you get when you square negative 12? You're going to get 144, won't you? So we'll go ahead and just put that down there. Then I usually slow it down for the 4ac business because you don't want to lose a negative sign along the way. And that's where I get a little paranoid. So I got the 4, the a is 3, and the c here is 4. Now sometimes the a and the c can be negative, like on another example in the notes, you see negatives all over the place. That's where you want to be careful. In this case, they're all positive, so it's not too bad, but just watch your negative signs. It's an easy way to follow the problem up. Down below, we have 2 times a, it's 2 times 3 is 6. All right, so now we're looking pretty good. This is about how fast you want to be working things. Keep going. So what's inside that square root is the next part here. Inside the square root, you got 144 minus this stuff here. What is that stuff? Well, it's 4 times 3 is 12, times 4 is 48. So 144 minus 48, what is that going to be? About 96? Yeah. All right, use your calculator if you have to. Now, you remember those problems we were looking at earlier in the assignment? Said simplify the quotient to lowest terms. It's exactly what we got here. Start with your radical. Square root of 96 is going to be plus or minus square root of 96. Should simplify this. There's a 16 in there. In fact, I'll just go ahead and write that there. You got 16 root 6. Let's go ahead and put that there so you can see it. And then out comes a 4. So you got 4 root 6. Now you want to do a little factoring. I don't want to take the 4 out because that won't cancel the 6 down below. So take a 2 out, right? Take a 2 out when you factor there. That'll cancel with the 6. Leaving behind a 6 plus or minus 2 root 6. Cancel the 2 with the 6 now, as you would expect to do. Here and here, leaving a 3 down below. And so now you get your answer in lowest terms. 6 plus or minus 2 root 6 all over 3. Make sure I'm still on the screen. That's a good thing to do. Let's see here. Yeah, I'm a little bit off there. So let's go ahead and move this up a little bit. Okay, now you can see it. So this right here is what we call the exact solution. That is the exact solution. And in most of the problems in assignment 3, that's precisely what they want, is the exact solution. There's actually 2 values there. There's a 6 plus 2 root 6 over 3 and a 6 minus 2 root 6 over 3. So sometimes they write in a more expanded format. You can look at the notes to see that. However, sometimes they want a decimal approximation, especially as you go into assignment 4 and you're going to get to the word problems eventually that have quadratic equations involved with them. They typically want a decimal approximation for a word problem. That should make immediate sense if you think about this for just a moment. Suppose you're doing a motion problem, and the question is, well, how long will it take to get to Grandma's house? No one wants to hear an answer like 6 plus 2 root 6 over 3 hours to get to Grandma's house. You say that to somebody, and you might get punched in the face. They want to have an answer like, 3.5 hours to get there. Something that makes some sense to them. They have some idea of how long it'll be. So let's take a moment to look at how to take an answer like this and produce a decimal approximation. It's not too hard to do, but it's definitely probably worth walking you through real quick here. And I have this in the notes as well. So let me erase all this. We're going to take that answer that we just had there and show you how to get the decimal approximations. It just takes a little care with your calculator. You got to watch yourself so that the order of operations doesn't accidentally foul you up. It's wont to do that sometimes. So let's see here. Here we go. So we'll call this getting decimal approximations. And it's something we have to do once in a while, especially for the word problems we get to later on in assignment 4. Not too hard to do, but if you have a calculator, you might want to check this out, see how this works. All right, so let's rewrite that answer we had before. It was 6. Well, before I even do that, remember this. Let me back it up just a second. The answer started this way. It was 12 plus or minus root 96. X was equal to 12 plus or minus root 96 all over 6. And then we went through a lot of work to get down to the final version of it, which was 6 plus or minus 2 root 6 over 3. This was the exact solution that we had at the end there. In fact, I'll just reiterate that right here. That was the exact solution. When they want the exact solution, they want it simplified as much as possible. That's what they're after. But if they're after a decimal approximation, you don't need to do all that because you're not going to see any of this. You're just going to have decimals for the answer. So the point is, you just stop right here. You jump ship right here. If you want a decimal approximation, you're going to jump ship right here. Don't waste your time doing all this other stuff where you simplify the radical root 96, and you factor and cancel. There's no need for any of that if you're after a decimal approximation. Now, how do you know you're after a decimal approximation? Well, if you're doing a word problem and all the answers are decimals, you'll know you need a decimal approximation. So don't waste your time doing all this extra jazz for the exact solution if you're after a decimal for an answer. All right, so let's take this here and get the two decimal approximations for it. So we have a 12 plus root 96 over 6. That's one of the two values there. And the other one's 12 minus root 96 over 6. This is going to lead to two decimal approximations for the answers. Now, how do you do this on your calculator? How do you avoid getting it fouled up on your calculator? Well, you got to be a little careful. Essentially, there's two ways to go about doing this. You could take your calculator out and type in 12 plus square root of 96, and then you say equals and get that value. That's your numerator. Then divide by 6 and get your final answer. That's one way to do it. The other way to do it, and I kind of prefer this, especially if you have a calculator with what I call a two-line display, so you can see what you're typing, and then you hit enter or equals and you see the answer on the second line, so it still shows you what you're typing. You can go back and edit it if you like. Well, if you have a calculator like that, it makes a lot of sense to use parentheses along the way. Basically, what you're trying to avoid is having the order of operations foul up your division by the 6. And so either you got to say equals before you divide by 6, or you got to wrap the whole numerator in parentheses. And by the way, you got to be a little careful about this because some of you have like TI calculators, and you've probably noticed this before on your TI calculator. Some of the other calculators do this as well. But when you hit the square root key on your calculator, it wants to pop up a parenthesis, doesn't it? So you hit the square root key and up comes a parenthesis. And then you say type in the number that say it's going to be, I don't know, 96 or whatever it's going to be. Well, then you got to close the parenthesis for the square root. And then if you're doing this red square root here, that would be a second parenthesis also. So you actually would have two parentheses in a row right there before you hit the division key and the 6. So be aware that some of your calculators, if you type the square root key and up comes a parenthesis, you'll have to do two parentheses in a row if you're doing this method. Now, the nice thing about this method, though, is if you're doing it with the parentheses, then all you have to do to get the second answer is you go back up above, use your cursor keys to edit this line right here and change the plus to a subtraction, change the addition to subtraction. That's all you have to do. You don't have to retype it in all over again. And that's a nice time saver. And it makes it a little bit faster, a little easier, less chance of making a mistake typing it all over again. So I recommend that. That's what I like to do. Anyway, here are the two values you're supposed to get. If you do the plus square root, it's going to be 3.633 approximately. And the other one's about 0.367. All right, so you should take out your calculator at some point and try to get one or both of those answers. I suppose if you can get the first one, you can easily get the second one. But just watch yourself. Again, you got to be a little bit careful. Two ways to do it. Either say 12 plus root 96 equals, divide by 6, or use the parenthesis approach, whichever you prefer. Let me point out a couple other things about using the quadratic formula that's probably good to know besides the decimal approximation idea. And you're not going to really need the decimal approximations much in assignment 3. It's assignment 4 where you're going to see them really crop up with those word problems. So that's why I'm mentioning it now, just so you'll know you'll get to it a little bit later. All right. Oh, by the way, one other thing I should probably mention too. It's in the notes. Read page 301 for how the quadratic formula can tell you whether something factors. So see page 301 for, you might say it this way, the crystal ball, if you will. Crystal ball of the quadratic formula. What it does is it can tell you ahead of time whether something factors. I'll just kind of give it to you in brief here. If you look at the quadratic formula here, this is kind of interesting. That's why I want to show it to you real quickly here without going through too much detail. But it's on page 201. Basically, think about it for a second. If you solve an equation by factoring, and like the first example I do in the notes with regard to the quadratic formula, I solve it by factoring because it's factorable. If you solve an equation by factoring, are you going to have any radicals in the answer? The answer is no. You're not going to have any radicals in the answer because where would they come from? You'd use factoring to get there. So what does that mean if I decided to use the quadratic formula instead to solve it? What it means is your square root would have to be friendly. It would have to go away. That means it would have to be something like maybe a square root of 49, or square root of, say, 36, or the square of 64, square of 25. It would have to be a friendly square root in order for the radical to disappear. On the other hand, if you got a square root of like 96 or square root of 72 or the square root of 30 or something that won't go away, what that tells you is there's no way that problem could have factored. Because when you solve a problem by factoring, there can't be any radical in the answer. Well, you sort of think about this for a moment and you realize this piece right here, the stuff inside this square root is key. The whole problem revolves around this, what happens inside there. They call this the discriminant. Discriminant. At any rate, it can tell you ahead of time whether a problem is factorable. If you take a quadratic equation and you calculate b squared minus 4ac, and it turns out to be what we call a perfect square, a number that has a nice square root to it, like these guys here, then it tells you the problem is factorable, that you could solve it by factoring. Now, what it doesn't tell you is how to actually factor it. So you may still be stuck if you can't see how to factor it. But it would tell you it was factorable. On the other hand, if you get a number that doesn't have a nice square root, like say the square root of 50, or the square root of 35, or the square root of 21, square root of 17, you know it doesn't have a nice square root, don't even waste your time trying to factor that equation because it can't happen. It's impossible. The answers to that problem are going to have radicals in them. The radical will not go away, and that means there's no way that you could solve it by factoring. So that's the crystal ball I'm referring to on page 301. You might want to take a quick look at that because it's kind of interesting. Though you don't need to know that to solve the problem, just letting you know, don't waste your time trying to factor if the discriminant is not a perfect square. Anywho, let's take a look at a couple other pointers here before we run out of time on this video. Where are we time-wise? Yeah, we're getting up there. Okay. So, minimize this. Just a couple of the quick pointers here when we have some time remaining. Not much time. Suppose you have an equation like this. 4/3 y squared minus 5/2 y plus 1 equals 0. Okay. Now, this equation turns out not to be factorable. So we have to use the quadratic formula to solve it. What's the first thing you should do, though? First thing you should do is clear those denominators. You know, the LCD here is what, 6. Multiply everything by 6, so just kind of go in there and say, okay, 6 over 1, 6 over 1, times that by 6. Of course, 0 times 6 is just 0. But you clear those denominators, that's going to give you 8y squared minus 15y plus 6 equals 0. And now use the quadratic formula on this guy. Because the last thing on earth you want to do is start plugging in gnarly fractions into your quadratic formula, because that's going to be a total nightmare. Don't do that to yourself. Clear denominators, plug in these values, and you'll have a much easier time of it. Now, decimals are a slightly different matter. It's okay to plug decimals into the quadratic formula. Let me give you a quick example here. Let me get rid of this stuff here. There you have an equation like this. 0.7r squared plus 0.3r and minus 0.2 equals 0. Now, you could easily plug these decimals in for a, b, and c into the quadratic formula, and it would give you in the end a decimal answer. And that's fine if you want a decimal answer. However, if you want the exact value, in this case, here's what the exact value for this equation looks like. In the end, the exact solution ends up being -3 plus or minus the square root of 65 over 14. If you want an answer like that, you're not going to get it by plugging decimals into the quadratic formula. So what do you have to do? You got to get rid of the decimals. Multiply, in this case, by 10, sometimes by 100, whatever it takes. But if you multiply through by 10 here, that'll get rid of those decimals, giving you 7r squared plus 3r minus 2 equals 0. Now, if I plug in the 7 for A, 3 for B, and -2 for C, that's going to give me this type of answer in the end. And that's what I'm after. That's the way to do it. You might just say, well, I don't like decimals anyways. I just clear them anyhow, even if I don't want the exact solution. Okay, I can see that point as well. At any rate, if you want an exact solution that looks like this, you got to get rid of the decimals. And that's pretty much it. I guess there's one other thing I could say. I just happened to think of it. One other little guy to point out, and this is probably pretty obvious as well. Suppose you got some really big coefficients, like 300x squared plus 500x, let's say, I don't know, minus 700 or something, right, equals 0. What do you think you want to do first with this equation before you run off and use the quadratic formula? Divide it by 100, right? You want to make these numbers small. You don't want to sit there and like square 500 to figure out what b squared is and all that kind of stuff. You want to divide everything by 100. That way you'll get 3x squared plus 5x minus 7 equals 0. And that's not going to be so hard to deal with. plugging 3 for A, 5 for B, and negative 7 for C is a whole lot easier than these huge numbers up here. So if you can divide out by some large common factor, by all means do that first before you run off and use the quadratic formula. Make your life easier. All right, that's it for this video. We're up to 20 minutes, my goodness. And next we're going to look at the substitution technique.